Welcome, everyone, to the AI Research Bites. This series of short and informative talk showcase cutting-edge research work from ServiceNow AI research team. The AI Research Bites are open to all, especially those interested in keeping up with the fast-paced AI research community. Today's session features a 15-minute talk from Amir Hossein Abbaskouri on his latest advancement on multimodal, multi-hop question answering. It will be followed by a 10-minute Q&A. Amir Hossein is a second-year master's student at the University of British Columbia, supervised by Giuseppe Carenini, and Issam Laraji at ServiceNow, and a member of the UBC's NLP group. His research interests include natural language inference, multimodal reasoning, and information retrieval. Up to you, Amir Hossein.
Thank you, Fanny. So I hope everyone can hear me clearly. So I'm going to present our work, FM2DS, few-shot multimodal multi-op data synthesis with knowledge distillation for question answering. This was a joint work with Spandana, Issam, and Giuseppe. And just this is the safe harbor notice, just to remind us that this presentation is based off our knowledge. Here's the agenda for my presentation. I will first go through describing and introducing what is exactly MMQA or multimodal multi-op question answering. Then I will go through the current state of AI tools in MMQA. And finally, I will talk about our approach, FM2DS, and conclude our work. So answering complex questions usually requires long readings. As a researcher, this may happen to you, or if you have been a student, this also is true for you. So you may have a question about a specific topic that there are multiple papers in there, and these papers usually include tables, images, different figures, which you need to interpret all of them, and sometimes comparing all of these information from multiple papers to come up with the answer. So multi-hop means that to answer your question, you need more than one document to answer the question. You cannot answer it only with one document. So in this case, you need multiple research papers. And multimodality means that you cannot answer it only with text or images. You need multiple modalities. You need to interpret images, text, and tables together to answer the question. And it's not only about researchers. We have this situation in other domains, such as medical documents, where you may have a question about a patient, and there are multiple information in different modalities, like the X-ray images or the tables, different charts, also textual information, medical reports and stuff. And you may need to interpret all of them to come up with the answer. So this is not just for researchers. This can happen in all the domains. And what we usually do in these cases is that we first need to read all the documents, understand them, and then find the relevant pieces of information that are required to answer the question. And finally, we put all of these pieces of information together to find the answer to the question that we have. So in a nutshell, MQA is complicated and time-consuming task which requires understanding multiple documents and modalities and would benefit from automation. And usually when we talk about automation, the first thing that may come up to our mind, especially nowadays, is ChatGPT. Let's see if ChatGPT can do a good performance, can have a good performance in MMQA. So let's consider this example. As you can see, we have three different documents that were linked with hyperlinks in this case. So one of them is about World War II, the other one is about Colorado, and the last one is about New York. And they have several pieces of information. And the question that we have in here is, what is the elevation range for the area that this eastern sector of Colorado, Oregon extends into? So to answer the question, you may need to find the pieces of information highlighted with red in here and put all of these things together to answer the question. Just a reminder, this is just multi-hop, this is not multimodal. We want to see if ChatGPT is good in answering multi-hop questions. So as can be seen in here, I gave this prompt based on the following documents, answer the following question. I gave all the documents and gave the answer, the question, and ChatGPT was able to find the answer easily in this case. But if we extend it to, what happens if we extend our question to multimodality as well. So we're going to have MMQA. Um, so as can be seen in here, there are the pieces of information I included from two different documents. One of the documents is about Qinshi Huang, which was the architect of Great Wall of China, and the other one is the document about Great Wall of China. And the question is asking about an image in the Great Wall of China. Document. And the question is, in the most important project of Qinshi Huang, what geometric shape was used in the watchtowers when looking from inside? And to answer this question, you should understand what was the main project of Qinshi Huang, which was Great Wall of China, and you should analyze that image in Great Wall of China document, and then come up with the answer. Where the answer in here is arc. But when I did the experiment with ChatGPT, I did the same thing. I gave the documents and asked the question, and ChatGPT was not able to answer the question. Even it was hallucinating, and it was giving the answer a square in shape, which is basically the typical shape for Windows. So it was not actually considering the images. So, and that's not the only limitation with ChatGPT. There are other limitations as well. One of them is that ChatGPT is expensive as well. So the cost of API usage increases based on the number of API calls that you do. And the other thing is that it's not a domain expert. So they may have some limited information and knowledge in some domain, in all of the domains, but they're not in-depth expertise. So FM2DS is here to generate synthetic data to train your smaller multimodal language model. So you are not paying that much for APIs, and you can have a specific MMQA for your specific domain. So what is the main idea behind FM2DS? So the main idea is to start, we have few human annotated data for MMQA and the documents for our domain. And we use the ability of ChatGPT in question answering and also NLP methods to generate a data set to train our smaller model. So one question that may come up to your mind until this part of presentation is that why we are not only using ChatGPT and just like doing these conversions and not training our smaller model. One reason is again the cost. You have to pay the API cost. The other one is that these NLP methods that are highlighted here are one of the important parts of our pipeline, which play a crucial role in finding the answer easily and filtering out the wrong samples. And then our small model can do MMQA for our domain. So let's go through the pipeline. So as it can be seen in here in this stage one, we create a pool of related documents, which we use Wikipedia pages in here. The next step is to group these documents based on topics and hyperlinks. We use a multimodal topic modeling approach, and also the hyperlinks mentioned in the Wikipedia pages to make different categories of documents. Some of the documents are grouped based on the topics that can be seen in here, like technology and entertainment, and the other ones are based on hyperlinks. And then we select one of these group documents. As can be seen in here, we selected music from Big Pink and Imagine album from John Lennon. So we have these two documents. In stage two, what we should do is we select case samples as in context example. We use multimodal QA dataset, which is a human annotated dataset, basically usually for multimodality, but they have samples with multimodal and multi-op question answering as well. So we use those samples and to come up with a few shot example. We use one shot example in most of our experiments, although we have more than one in context example as well in one of our ablation studies. And we use these few shot examples as well. And in stage 3.5, we generate the question. So the question generated in here based on the featured example and the selected relevant documents is this: between the album featuring a man bending on a piano and the album that includes the song I Don't Want to Be a Soldier, which one is older? So the image that was mentioned in here also is included in this part. So we have an additional step which will use it in stage 4. In this step, we use all the images and the question generated to generate caption captions based on the information requested in the question. So as can be seen in here, the caption generator is talking about that musician or the person that is bending on the piano in this image. Um, in stage 3.2, we validate our question. We use different approaches, but the main ones are checking that if the question is really a multi-hop question and checking if the question is a really multimodal question, which we do it by removing all the modalities except one and removing all the documents except one to check if this is true. In stage 4.1, we use both the generated question, which was validated as well, and those captions to generate an answer. So the answer, we generated one short answer and one long answer in here to just interpret and increase the interpretability of our pipeline. In stage 4.2, we validate our answer, which we use named entity alignment and hallucination checking. Where in hallucination checking, we ask the model 5 times to give us the same, give us the answer to the question. If it is giving us the same answer over and over in the 5 times, so we can say that the model is sure about the answer it's generating. It's not hallucinating in there. And in stage 5.1, we have the knowledge distillation part of our pipeline, as we talked about it in the title of the project. We generate queries. The queries are the steps that should be taken to come up with the answers. So in here, we are talking in this stage 1, we are talking about you should use the image from music from Big Pink that shows that musician, that a person is bending on a piano. In the next step, you should look for the time that the music from Big Pink document shows the album was released in 1968, and then in the third part you should retrieve this information that the band album was released in 1971. So you have all of this information and you can say which one came up sooner and or which one is older. Also, we have query validation as well, which we use top 5 document retrieval to do so. And finally, we have our sample for data set, which are like appended together to create FM2DS training data set for the domain that we want. One question that you may come up with is that if ChatGPT can answer MMQA easily, does it affect the pipeline when generating and validating the answers? So here's the thing. So in this part that we were generating question-related captions, it plays a crucial role as as we see when we're experimenting with ChatGPT. ChatGPT may ignore the visual information and the images in the documents when it's faced with multiple long documents. So like replacing, we are not replacing the images, we are adding the information, but adding some of these captions with these images can make the ChatGPT's work easier to come up with the answer. And also, let's go through some of our results. As can be seen in here, we have done experiments with multiple models from Lava, InternVL, IDFX, and we have additional models. You can check them out in the paper. But as you can see, we have trained these models, both our synthetic data and real data. And by real data, I mean human annotated data. And as you can see, we have improvement in EMS score or exact match score in all of the cases, which can be seen easily in here. And also, our experiments shows that FM2DS makes the learning curve faster. So you learn faster when you're doing hard work. And the two reasons we hypothesize that this is happening is one, the queries that we have, and the other one is that we are doing a harder task compared to the benchmarks that we are using here, which is multimodal QA and web QA. And we can now go through qualitative analysis. So as can be seen in here, we have these information snippets. And the question is which artist released an album in December 1969 featuring a record on its cover. And the album featuring a record on its cover is Let It Bleed, as can be seen in the right image. And the answer is the Rolling Stones. So as you can see in here, these are the models that were trained by real data in here. So as can be seen, Lava is not giving us the correct answer, is giving a completely wrong answer in here. IDFix is not even giving an answer that was that is in the documents. So the details was not in neither of the two documents that we have, so it's hallucinating in here. And InternVL is giving us the correct answer. But when we fine-tune the same models on our synthesis data, Lava still cannot answer the question, which might be due to the reason of its architecture and its simplicity. But IDFix is giving us the correct answer, which can be related to the fact that our model is teaching these small models how to find the answer for um, these like complicated tasks. So to conclude, we propose FM2DS framework, which is for synthesizing multimodal multi-hop question answering data and to train a smaller model to answer complex questions in your domain, and which enables complex question generation with minimal human effort. And for the future work, there are several ways to improve this work. One of them is incorporating multilingual context. We have tested our approach only with English corpora, but this might and it might have some problems with other languages or in the multilingual context as well. You can integrate video based on other diverse modalities. We have only included tables, text, and images. And also you can include code snippets and program-related question answering samples. And thanks for your attendance. If you have any question, you can ask it in the 10 minutes QA time, or if you want, you can like contact me via this email mentioned in here. And I suggest you to check out our work based on these two QR codes. One of them is for the archive version of the paper, and the other one is to the GitHub repository. Thank you.